The next time a train rushes past you, don't watch the engine. Look down. Under the steel rails, under the sleepers, you'll see the same thing everywhere on Earth. Stones. Rough, sharp, ugly stones. Millions of them, laid carefully, stretching for thousands of miles. It doesn't matter if the train is slow or high speed, old or modern, in Africa, Europe, Asia, or America, the stones are always there. And that leads to a simple question that almost nobody asks. Why? Why do we support one of the heaviest machines ever built on loose rocks? Why not concrete? Why not steel? Why not something stronger? The answer is smarter than it looks, and it's one of the most important ideas in railway engineering. Let's start with the problem engineers had to solve. Trains are heavy. Not just heavy, extremely heavy. A fully loaded freight train can weigh more than 10,000 tons. That weight is not standing still. It is moving, shaking, braking, turning. Now imagine placing that force directly on the ground. The soil begins to collapse. The earth compresses. The track sinks. Even a few centimeters of movement is enough to bend rails. Bend the rails and the train becomes unstable. Unstable tracks lead to derailments. Early railways failed often because of this, so engineers needed something that could carry massive weight, stay stable for decades, absorb vibration, survive rain and heat, and still be easy to repair. That solution was not solid. It was loose. A railway track is not just rails on the ground. It is a system. Picture it in layers. At the top, you have the steel rails. They guide the train's wheels. Below them are the sleepers, also called ties. They keep the rails in position and evenly spaced. And below everything is the most important layer, the stones. Engineers call this layer ballast. The ballast is the foundation of the entire railway. Its main job is simple. It spreads weight. Instead of all the pressure pushing straight down into the ground, the stones spread it out across a wide area. Less pressure, less damage, more stability. Without ballast, the track would slowly disappear into the earth. Here is something surprising. Railway tracks are not fixed solidly into the ground. They are not cemented. They are not locked in place. They float. The sleepers sit on the stones. The stones hold everything together using weight and friction. This floating design is intentional. When a train passes, the track moves slightly. It bends. It vibrates. That movement is healthy. If the track were completely rigid, it would crack under stress. Metal would fatigue. Concrete would fail. The stones allow small movement without destruction. They act like a shock absorber, strong but forgiving. Now let's talk about the stones themselves. Why do they look so rough? Why not smooth, round pebbles? Try standing on marbles. You would slip immediately. Smooth stones roll. If railway ballast were smooth, the stones would shift under vibration. The sleepers would slide. The rails would drift apart. That would be dangerous. So engineers used crushed stone, granite, quartzite, hard rock smashed into sharp pieces. These stones don't roll. They lock together. Their jagged edges bite into each other, forming a solid mass, strong enough to hold a train, flexible enough to survive movement. That balance is critical. Water is one of the biggest enemies of railways. When soil gets wet, it becomes weak. It turns into mud. Mud moves. Concrete is not perfect either. Water pools on flat surfaces. Moisture stays trapped. Steel rusts. Ballast solves this problem naturally. The spaces between the stones let water flow through instantly. No puddles, no trapped moisture. Rain comes, water drains away, the foundation stays solid. This is why railways can survive heavy storms and floods. The stones act like a giant drainage system. There's another reason you don't see forests growing on railway tracks. Plants need soil. They need stable ground. Ballast offers neither. Sharp stones make it hard for roots to grow. Seeds struggle to settle. Plants die before they can spread. This matters because roots can lift sleepers and weaken tracks. By stopping plant growth, the stones protect the railway long term. No chemicals, no technology, just smart design. The name ballast did not start with trains. It started with ships. Old wooden ships had a problem. When empty, they were too light. They moved dangerously in waves. So sailors filled the bottom of ships with heavy stones. This weight kept the ship stable. That weight was called ballast. When ships reached port and loaded cargo, they dumped the stones. Early railway builders saw piles of these discarded stones and realized something. They were heavy, cheap, and perfect. They used ship ballast to stabilize railway tracks, and the name stayed. A solution from the ocean became the foundation of modern railways. So the next time you see a train, remember this. Those stones are not random. They carry the weight, absorb the shock, drain the water, fight nature. They are one of the simplest and smartest engineering solutions ever created, hidden beneath your feet, quietly keeping the world moving. If you enjoyed this video, please subscribe to the channel and stay tuned for the next. Thanks for watching.